The cable television industry uses a standard channelized frequency allocation on their distribution system. Downstream channels start at channel 2 and go up beyond channel 125. You've got a copy of this table in your workbook, so look at it. The table gives the channel allocation frequency and visual carrier frequency for each channel for 3 band plans, the EIA standard plan and the older IRC and HRC plan. Cable companies were required to begin using the EIA standard frequencies prior to 2000. By using digital compression techniques, cable companies can squeeze 6, 8, or more digitized NTSC channels into a single 6 MHz channel space, greatly expanding their potential channel capacity. But it requires a digital set-top box to convert those channels back into NTSC analog format. The amplitude of cable channel signals, as well as all RF signals we'll be using, are expressed in dB or decibels. They're used to express the ratio of any two values, such as power or voltage, and greatly simplify calculating gains and losses of RF systems and components. For example, if we know the signal into an RF amplifier is 1 volt and the output is 2 volts, we know by this formula that the amplifier has a plus 6 dB gain. Likewise, if we know the signal into a length of coax cable is 1 volt and the output at the other end is 0.3 volts, we know the coax has a loss at the frequency of the signal of minus 9.5 dB. By convention, the minus sign means a loss. This is a table of common signal level dB gains and losses. Notice that increments of 20 dB voltage gain or loss is equivalent to powers of 10 increase or decrease. Plus 20 dB is equal to a 10 times increase. Plus 40 is equal to 100 times, and so on.
Fortunately, when designing an RF distribution system, the dB gain or loss of a particular component, like an amplifier or the coaxial cable, is given to you by the manufacturer. So all you need to do is add them together for each path through the system.
For example, if we know that the loss of a brand of coax cable is 8 dB per 100 feet, then this system, with 100 feet from the cable service NID to an amplifier, with 10 dB of gain, then another 50-foot length of coax to a TV, will have an overall gain or loss of minus 8 and plus 10 and minus 4, or a total of minus 2 dB of loss. So if we know the input signal level, we can easily figure the output signal level.
While dBs express a ratio, absolute cable company signal levels are typically given in a unit of measure called a dBmV, or decibel millivolt. The MV after the dB means an absolute signal level reference to 0 dBmV. 0 dBmV is a standard reference level of 1 millivolt of the visual signal level across a 75 ohm resistance. 75 ohms because the cable system is built around 75 ohm impedance cables and equipment. A 3 dBmV signal has a level of 1.41 millivolts across a 75 ohm load, and a 10 dBmV signal has a level of 3.2 volts. Likewise, a minus 6 dBmV signal has a level of 0.5 millivolts. A minus 3 dBmV signal applied to an amplifier with a 10 dB gain would result in an output signal level of plus 7 dBmV. We'll talk more about amplifiers and amplifier gain shortly.
The cable company's visual signal level at the NID or connection point at the house should not be anything less than plus 3 dBmV on any channel.
Now, the signal level in the house at the point of connection of the customer's equipment should not be less than 0 dBmV on any channel. Now, the only upper limit given in Part 76 is, I quote, a maximum signal level such that signal degradation due to overload of the subscriber's receiver does not occur, or something like that. Now, that's usually a maximum of plus 15 dBmV, and ideally in the range of 0 to plus 10 dBmV. This is also the range that the cable tuners in televisions are designed to handle.
RF signals can be easily measured utilizing a portable signal level meter like this. This unit will make any number of key measurements on any cable signal or off-air signal with an input range of minus 35 to plus 60 dBmV.
All broadband services use coaxial cable. Like TP cable, coaxial cable comes in various performance ratings established by cable standards organizations.
The coaxial cable is constructed very differently from twisted pair. It consists of a center conductor surrounded by one or more shields. The cable is divided into numbered series with common characteristics in each series.
Now you can think of coax as sort of a two-wire cable where one of the wires has been flattened out and wrapped around the other one. Now the center conductor is usually 18-gauge solid copper or copper-clad steel for strength. The shields are separated from the center conductor by a dielectric insulation, typically foam polyethylene. Now the cable may have a single foil or braid shield or a combination, such as this foil, braid, and foil. A quad shield cable will have an extra braid. The inner foil is used for shielding as well as being one of the signal conductors. Now a braid does provide a shielding, but it's primarily used for the cable strength. Extra foils and braids provide extra interference protection and extra strength. And finally, an outer PVC jacket covers